Hi everyone, I'm very glad to give you a quick talk about the possible roles of BS models in past stock market crash. I will give you my conclusion right now. That is, in my opinion, the BS model is invalid or even makes things worse if we have a financial crisis. To make my conclusion clear, I will explain it by both empirical method and a mathematical method. From empirical method, I have to say any mathematical model which is applied in real life relies on simplifications and assumptions. The BS model is based on arbitrage pricing theory, which is widely used in financial theory, but it always falls in real life. It requires no transaction cost, no limits on short selling. You can borrow or lend money at fixed risk-free rate, and you can divide an option and a share to very small. However, this is all impossible in real life. Sometimes special financial instruments can be so complex that modeling them requires too many assumptions, so it's very hard for us to approximate an exact solution. For example, in 2008, there is a special kind of derivative, which is CDO. That they are not associated with a specific mix. Additionally, the CDO models use assumption which underestimate the correction of movement of the parts of the mix. So it is very hard to estimate the price of CDOs. Besides, models can have other problems that are more social than mathematical. For example, when we have a financial crisis, people will rush to sell their holding stocks to avoid a larger loss. However, at that time, everyone chooses to sell their stocks. It will increase the volatility of the stock. And as we all know, the volatility is the only parameter in BS model we need to estimate. So, with the increasing of volatility, the value of BS model will change greatly. Here is an example. The stock is American Insurance Group, AIG. I picked the time interval begin from November 2007 and ended it at November 2008. In that period, the global financial crisis is very serious. Now, according to the R code, I get the adjust close price, and I log them and calculate the difference. Now I use the logarithm to plot a histogram. From the we can get the conclusion that the stock price doesn't follow a normal distribution. That also helps to explain why the BS model won't work in a financial crisis. So, no one knows the correct value of the derivative. They just sell them in a panic. However, it's unreasonable to sell it in such a low price. You have to protect the cash of your portfolio. To protect the cash flow, you have to sell the option or stocks. However, no one buys them at that time in the stock market. You have to adjust them to a lower price that will increase the volatility and it cause a bad circle. We should remember that the BS model doesn't fit the great volatility because the model is under the assumption of Brownian motion, which means the jump process, the jump in price are always small. Since I just mentioned the problem of volatility, I have to point that from a scientific way, the method to estimate the pyramid is to evaluate the outcome from the past to determine the pyramid. We have to be careful that the assume past is a reasonable predict of the future. It is useful in the physical world where physical parameters don't change. However, such a phase in the economical environment, consumers, producers, and investors are changing habits suddenly in response to bubbles or stock crashes or some big news. The changes in economic behavior changes the parameter. That's the reason I think the BS model is valid when we have a financial crisis. To explain my conclusion via mathematical method, I have to introduce you two conceptions. First is volatility smile. There are several explanations for the volatility smile. The volatility smile may be explained by investor demand for options of the same expiration date but different strike price. In the money and out of money options are usually more designed by investors than at the money options. Because the increasing demand makes the price of such options up, the implied volatility for those options seems to be higher. Another explanation for the strike price implied volatility plot is that the options with strike price increasingly further from the spot price of the underlying asset account for extreme market moves or black swan events. Such events are characterized by extreme volatility and increase the price of an option. Since we have some basic idea about what is the volatility smile, now I will begin to discuss the volatility surface with BS model. Of all the variables used in Black-Scholes model, the only one that is not known with certainty is volatility. At the time of pricing, other variables are clear and known, but the volatility must be an estimate. The volatility surface is a three-dimension plot where the x-axis is the time to maturity, the z-axis is the strike price, and the y-axis is the implied volatility. If the Black-Scholes model were completely corrected, then the implied volatility surface across strike price and time to maturity should be flat. However, in practice, this is not the case. The volatility surface is far from flat and often varies over time because the assumptions of the Black-Scholes model are not always true. For instance, options with low strike price tend to have a higher implied volatility than those with a higher strike price. And for a given strike price, implied volatility can be increasing or decreasing with time to maturity. That's the reason how we can shape a volatility smile. As time to maturity approaches infinity, volatility across stock price tend to converge to a constant level. However, the volatility surface is often observed to have an inverse volatility smile. Options with shorter time to maturity have larger volatilities than options with longer maturities. In this figure, this figure shows a snapshot of the volatility surface for the Euro index on November 28th, 2007. At that time, the financial crisis is very serious. Yes. The principal features of the volatility surface is that options with lower strike tend to have a higher implied volatility. For a given maturity, the surface is typically referred to a volatility smile. For a given strike, the implied volatility can be either increasing or decreasing with time to maturity. In general, the surface shows that the BS model doesn't perform well. Now I have finished the discussion about the imperfection of BS models. Now I will begin to discuss how to adjust the BS model in stock market crash. To adjust the BS model, we have to extend the application. As we all know, the BS model follows the rules that the return of the log stock price should follow a log normal distribution. However, when stock price crashed, people sell their holdings without reason. Yes, because there's a panic selling. So the stock price will go down in a very short time, and it's hard to estimate the volatility. I advise to use a mixture of log normal distribution, and I know it from a book which is Financial Modeling and Non-Constant Distribution. This model is frequently used in literature, and it can generate variety shapes that shapes are deviating from normal distribution. This probability is very important because according to the empirical observation, the stock price is quite different with normal model when a crash happened because everyone just want to sell. Many extreme events happen. Which are supposed to have a small probability and a normal distribution. This description meets the feature of fat tail distribution. To fit that situation, we have to use a mix of log normal distribution. Now let's have an eye on the log normal distribution. Here is the PDF of the log normal distribution. ST means the spot price, S means the volatility of the stock price, and mu means the return of the stock price. And by combining the different log normal distribution, we can get a Q function. Here in the Q function, we use a theta to regroup all the unknown parameters such as alpha, mu, s, and we have been aware that alpha here means the weight of different log normal distribution. So the summation of alpha equals 1. So we can get the operation price for such a mixture of log normal distribution. And to simplify the notation, Q is a convex combination of the various log-normal densities, and the operation price for such a mixture of log-normal distribution is here. After the integration and simplify the notation, we can get a formula in this way. We write the co-option price of mixture log-normal distribution as follows. In this way, we can understand the mixture of log-normal distribution is a slightly modified about usual Black-Scholes. In this case, we can clearly understand that the using of a mixture of log-normal distribution is a slightly modified about BS models, and we have to be aware that in the new formula there is additional mu. It can not only describe the annual return about the assets, but also can explain the excessive drift when the financial crisis happened. Log-normal distribution is one of the parameter methods to estimate the stock price when financial crisis happened. Apart from it, we still have a semi-parameter and a no-parameter method, such as the edge-walls expansion, the spanline method, the tree-based method. We just to remember that all these methods have both pros and cons. All we can do is to apply them under a reasonable assumption. Okay, so far I have discussed the reason why BS model unwork when financial crisis happened with an empirical method and a mathematical method. And I also advise that to apply the BS model in the special case, we need to change the distribution to describe the excessive drift. We'd better use a mix of log-normal distribution. Now, the following is my reference and bibliography.